In this lesson, we're going to talk about present value. And it's very much related to what we did previously when we talked about compound interest. And most of the examples in the last lesson, you were trying to find out how much do you have in the future. But now we're switching the question a little. We are asking, how much do you need today in order to reach a specified amount in the future? And obviously, you're going to make some assumptions with the rate and the time. Okay, so I know you see a new formula here, but this is actually a rearrangement of your previous formula, and then we just we made new variables here. So PV is for present value and FV is for future value. So what we really did was take our compound interest formula and just isolate it for P, because you want to know the amount you need today to make something happen in the future. So divide both sides by all of 1 plus I to the power of n. And there you go. That will find you the present value. So I know these formulas look different, but they're exactly the same. So PV is just P really, and V is just A from before. And you have a negative exponent, but no problem. Remember, negative exponent means you're repeatedly dividing instead of repeatedly multiplying. So that's what we see. So please don't see this formula as something new. It's basically what you did yesterday or in the previous lesson. All right. So Sammy wants to invest money today to have $3,200 for tuition when he goes to college in 5 years. You know what? Before we keep going, good job, Sammy. He's planning for the future. He knows he needs this amount. So he's going to try to let his money work for him. Okay? Now, you're going to see it's not going to do... you're not going to earn that much interest because it's only 5 years. You're letting your money work for you. But you know what? It's better than nothing. So let's take a look. So the present value is equal to $3,200. That's your future value times 1 plus 0.06. And it's compounded monthly. So 12 times a year for 5 years. So that's 60 compounding periods. Be careful. Negative 60, okay? Negative 60. Because you're trying to the present value. So we're looking at 2372. So he needs to invest $23.72 and 39 cents today, right now. Okay, get on it, Sammy. Let your money work for you. Okay, that's in fact how most people get rich. They let their money work for them. Instead of spending the money, they put the money in a safe place where it grows. Those are your options. All right, so let's look at another example here. Jim needs $5,007 years to start his own business. He's going to invest his money at 9% per year compounded annually. How much does he need today? Once again, calculate the present value. So you know the future value is 5,000. So it's compounded annually. Perfect. So it's once a year for 9 years. That's 9 compounding periods. So we're looking at $2,300, about $2,300. He needs to invest $2,300 today. All right, now let's have a look here. How much of the 5,000 is interest? Okay, he's gonna have 5,000 in the future. 7 years in the future, he's gonna have $5,000. But he only put in 2,300. About 2,300 was his money. So what's not his money? His money earned through interest. Let's PV. So we're looking at about $2,697.86. In fact, he earned more money if you compare the amounts, the present, like how much of it of the 5,000 was his money and how much of the 5,000 was the bank's money, more of it was the bank's money. That's a big win. But this is a really strong rate, 9%. It's definitely not through a bank. It's through like some stock or something. At least in 2020. Those rates are unheard of nowadays. Is interest. All right. So let's look at some scenarios where you're spending money. Julianne is purchasing a used vehicle from a car dealer, and the dealer offers 2 payment options. So plan A is $3,750 right now. Plan B, you pay $1,500 right now, that's your down payment, but then you have to pay additional $2,300 in 1 year. So which one is the better option? Which one is cheaper? Well, let's think about it. Plan A, the present value is $3,750. $3,750 now is $3,750 now. There's nothing interesting about that. Now, a lot of students, when they see Plan B, they say Plan A is better because this is what they do. $1,500 plus $2,300. That is $3,800. And $3,800 is clearly greater than $3,750. But be careful. The benefit of Plan B is you get to hold on to your money. And you get to hold on to your money and let it grow. So maybe it's a better idea to hold on to this $2,300 for 1 year, okay? Or hold on to some amount and let it grow to $2,300. Maybe that's a better idea. You know what? If that's confusing, we need to calculate the present value of $2,300. Now, we're going to assume that these are the rates, okay? So 4% per year compounded semi-annually. So is it a good idea to hold on to your money and grow it to the $2,300 you need in a year? Let's take a look. Well, the $1,500, that's $1,500 right now. That's the present value. But for the $2,300, what is the present value of the $2,300? Under these conditions, you know what? Let's take a look. It's actually, you need $2,210.69 right now to build up to the $2,400. Okay, that's the benefit of holding on to your money. You can let it grow into the amount that you want in the future. So, what is, if you take this present value and you add by 1,500, you get 3,700. Ooh. Interesting. So you can actually use a smaller amount today to purchase this car. Okay, so between Plan A and Plan B, I'm definitely choosing. So since PV sub A is greater than PV sub B, therefore choose Plan B. It's cheaper, right? You have to find out what is $2,300 in today's money, because this $2,300 is 1 year in the future. But what is that worth in today's money? So obviously you need to know what the rate is. You need to know how much time we're talking about. But so we're talking about 1 year, and it's 4% per year compounded semi-annually. So you need to know the conditions. But you can't make the comparison without doing the present value of $2,300. Because if you just add $1,500 and $2,300, that's apples and oranges. This is 1 year in the future. Okay, so is this realistic? Probably not. Usually, not always, usually when a car dealership offers you these kind of options, it's going to be cheaper if if you pay everything up front, usually, okay? Not always. The best thing to do when you buy a car, do your research, okay? And then hopefully you won't get scammed. So, one more question here. Lamar wants to borrow some money to buy a motorcycle. He wants $12,000 in 5 years. So there's Regal Bank offering this rate, and there's Suburbia offering this rate. So you know what? Let's just do the two calculations. There is a different way to do this, but I'll do it the more, I think, more intuitive way. So for Regal, let's calculate the present value of Regal Bank, and then calculate the present value of Suburbia Credit Union. So in both cases, you're going to end up with $12,000, okay, in the future. So Regal is 1 plus 0.089 compounded semi-annually. So looking at 2 times a year for 5 years. For Suburbia, you're going to have to pay back $12,000 in the future. Oops, not $120,000, $12,000. $12,000, and the interest rate is 8.4% compounded monthly. So 12 times a year for 5 years. That's 60 compounding periods. I wrote 120,000 2 times. Oh my goodness. Okay, so that means Regal, the present value of Regal Bank is 7764. And what about for Suburbia? We're looking at $7,702.53. So which one are we going with? Are we going with Regal or Suburbia? Well, let me give you a hint. Regal is giving you more money today. And if that's the case, why am I not going with Regal? He's giving me more money today. In both cases, I'm going to pay $12,000 after 5 years. So you want to take more money today. Okay, whereas in the previous example, you want to pay less money today because you're paying, as in this case, you're getting money. So basically the same idea, but in a sense, opposites. Okay, so choose Regal. All right, so that's it. Now I do want to do a quick calculation, but I'll save it for the next lesson because our next lesson is super important. It's our get rich lesson. It'll teach us how to be filthy rich in the future.